seeing here is that we're seeing our three tunics. There. Oh, too dark now. Okay. Still not as bright as it is. Good enough. This is the intima, right? Oh, come on now. Really can't do this. Stop that. Huh. I don't know why it's not. Huh. I've done this hundreds of times. Now it's working. Oh. Well, it's best. Sure it's not a Monday? Feels like a Monday. Well, I do the best I can. So this is a 40x image. This right here, what are you supposed to add? That's the intima, right? It's just thin little black line. The thin little black lines, that's actually the internal elastic membrane that you're seeing. Okay, so that's the intima that we're tracing there. And then this whole layer here would be the media, and that's pretty much just smooth muscle with a collagen fiber. And then this is the externa. Okay. Now that's an artery. If we take a look at this guy, if you looked at that histology slide, you would see, never had some trouble getting the light out. That vein is running right next to that artery in the actual slide. This is a 40x image, and I can't fit it all in the field of view. So I made the panel this way. Well, what's the most obvious thing you see there? Well, it's collapsed. This lumen in here is all oddly shaped. Okay. Oh, gee, crispy. Boy, it's pretty. Usually I can move that in and out like that, and I don't have to adjust this every time. Good. Okay. So the lumen's collapsed. That's the most notable thing you see between a vein and an artery. Usually the vein lumen is collapsed. And then look here. The media is super thin. In fact, over here you can't even see it. It's almost absent there. Here you can see it. But compared to that artery, remember this is the same power that we're looking at. Compared to the artery, the media is much, much thinner. Now, what do you think the lumen size of that is? If I were to open that up, the lumen size of this would be
Huge.
Yeah, I don't know. I mean, it might even be bigger than our field of view. It'd be probably that big compared to the artery, which is only about like that. So veins tend to have much larger lumens than do the corresponding arteries. And then this is all external out here. So that's a muscular vein. The other one is a muscular artery. And then I went up on a higher power. I went to the next higher power and I looked at them. So this is the artery again. So here we're seeing this is the intima, and then there's the media, and then there's the externa. That's about as clear as they'll ever get. Okay, you can clearly see those without too much trouble. Any questions about that? Then that's the vein. That's just the vein blown up a little bit. So the intima looks about the same, but then the media is very much diminished. What's that?
And then the white center's where the blood would flow.
Yeah, the white's the lumen. Right, that's where the blood would be. This one, I panned off to the side. Now this is the externa of the vein, I believe. No, this was the artery. This is the artery, starting here. But then I went out into that loose connective tissue, and I'm looking at these little spots. What do you suppose those are? Yeah, those are actually capillaries. Yeah, that's the relative size. That's a big capillary. That's more like a typical small capillary right there. This down here is the vein. Whoa, got really big really fast. So capillary, capillary. When you're trying to figure out if something's a capillary or not, you look around the outside of it, and if you see any smooth muscle out here, it's not a capillary, it's an arterial. But if you don't see any smooth muscle, then it must be a capillary. And none of these have any smooth muscle associated with it. Look in the variation in size. That's a capillary there. So are these. But that is also. So even within capillaries, you can have quite a variation in size. Capillaries can go from about 5 micrometers up to about 40. That's about the size. All right, zoom in on them there just to show them a little bit more detail. So this is up, I think I put this up on 400x power to see it. Gosh. At that level. So that's the capillary there, and there's nothing else around. This is all collagenous connective tissue and macrophages and things like that. Then I switched slides, because that particular slide didn't have a good example of arterioles, so that's what I picked this one for. Get over here really dark. This is the wall of an artery, a fairly large artery. Now you come over here and you look at these, and these are about the size of capillaries, but you can actually make out there's a tunica media there, and that's smooth muscle, and this is the elastic fiber on the outside. So that's an arterial, and this, which is all collapsed right here, is a veiny one. And how about, what do you think this is over here? All right, that's an air bubble. But that's the reason I asked that is because that looks a lot. Whoops. Sorry. No. What you might call technical difficulties. Because that air bubble looks a lot like a vein. But you have to look at the wall here. So in this, I can see some tissue, some dark staining tissue there. That's just an outline. I think I took a higher magnification picture of that. Yeah, there you go. So if on a test I had the pointer pointing to something that I have right there, what you need to try to do is realize that you are seeing smooth muscle. Okay. So this stuff right here, that's smooth muscle. That's an elastic membrane, that's an intima, this is the media, and this is externa. And that stuff in there, those are red blood cells. How about this? You think this would be a capillary or an arterial? It's still an arterial. Yeah, it's got to be one cell layer thick of smooth muscle around that. And even this one too. Okay. Actually don't see a capillary in this current field. That's probably a capillary. I can't see it. All right. So the objective is for you to be able to identify vein, artery. In the large vein and artery, you should be able to identify the 3 tunics. And then be able to differentiate an arterial from a venule and a capillary. That's what I expect to be able to do on the histology slide. Okay. I give you enough show and tell there for you to be able to do that? Okay. Other than that, I think I should probably introduce the circle of Willis. So there's a special cerebral adaptation we have for the brain there are 3 ways the blood can get to the brain. Okay, that's it, 3. So we've got the carotid arteries that come up here, and you've got a right and a left, common carotid. Now when they get to just below the angle of the mandible, right about here, you meet an area called the carotid sinus, or carotid body. And that's a widening, right there, where the internal carotid and external carotid split off. Now the external carotid comes out around from behind the ear and feeds all of the facial arteries. So your auricular and temporal and all those things, those all come from the external carotid. That blood does not go to the brain. That only goes to the facial arteries. Okay? The internal carotid, this guy, comes in underneath the occipital bone and goes through the carotid foramen, or the foramen lacerum, and goes up into the cranial vault. And that feeds blood to the base of the cerebrum. And that's what's happening right here. Now at this point, on this model, because it only shows the left of the arteries, it doesn't show everything, it just shows half of it. But we've got 3 cerebral arteries. There's an anterior, a middle, and then this tiny little guy back here, a posterior. So the anterior cerebral artery goes to the frontal lobes, the middle one goes to the parietal lobe, and the posterior goes back towards the temporal lobe, okay, and the occipital lobe. So those are your 3 cerebral arteries. Well, they all come off of the circle. So the circle on this one's not really shown, there's just a wire tie here. So you come into the circle via the internal carotid, and then you can travel around an anterior or posterior communicating artery, which are just super tiny little arteries that take the blood either on the anterior part or the posterior part of the circle. And then those 2 communicating arteries can feed the other half of the circle, which would consist of these 3 arteries again, but over here. Now you can see all of those on the skull model when you get one that's not broken, okay? The other way blood can get into the brain is by these guys, the vertebral arteries. So the vertebral arteries come off of the subclavians, okay? And they go up through those transverse foramina within the cervical vertebrae. If you remember studying the vertebral column, the cervical vertebrae all have these transverse processes with holes in them. It's the vertebral arteries that go through there. So they come up there, and then they converge actually after they pass through the base of the skull in the foramen magnum. They come in there, and they converge, and they make this thing right here, which looks like a centipede or an antenna. And the artery that goes through that is called the basilar artery, and that feeds into the back of the cerebral circle. And then again, we can go around the circle and go to any of the cerebral arteries. So your 3 ways to get to the circle are basilar artery fed by the vertebrals, or you can get there via the left common carotid or the left internal carotid or the right internal carotid. I guess, yeah, right. Yeah. The left one internal is here, and the right one is cut off because they cut the common here. So you'd have 2 of those coming up into the circle. So make sure you can identify the parts of the circle. Usually I don't ask the circle on this model because it doesn't really show you the circle. I could ask you the cerebral arteries, or I could, of course, ask you the vertebral or the internal carotid. But if I ask you the circle, I usually do it on the skull model. Okay? And if you want me to come around and point it out to you specifically the way you studied it, I will, of course, do that.